We all know good workers are hard to come by, especially on the farm. But what if you had employees that didn't watch the clock, didn't care if it was a weekend or holiday, and were capable of providing individualized care to every single plant in your field? Well, on this week's Between the Rows, we'll be learning about Tom, Dick, Harry, and Wilma, a team of robots that might be coming to a prairie farm near you in the not-too-distant future. I'm your host this week, Laura Rance. I'll be talking to a British company that's using artificial intelligence to make farming smarter.
Well, the key thing that we're doing here, I think, is rethinking how a farmer can see their crops.
We'll hear from a Saskatchewan farmer about the potential he sees for this new technology on prairie fields.
Well, what excites me the most is the potential efficiencies long-term, the potential safety, benefits to the environment and sustainability. There's just so many things.
And we'll hear from a long-time ag tech entrepreneur about how the whole innovation game is changing in agriculture.
I love it. I love the fact that these people are young and passionate and they want to take an idea. Next challenge for them is to, commercialize it and then scale it.
But first, here's a word from our sponsor.
We knew we were doing something right when our competition started swearing every time they talked about us. Just the other day, I heard someone saying, "Have you seen this f***ing Seedmaster Ultra Pro 2? They got third-party PAMI testing that confirms its individual row metering delivers uniform seed placement, near zero seed mortality, and no impact on germination results." We take it as a huge compliment. Start raising your ROI at seedmaster.ca.
Well, as every Tom, Dick, and Harry knows, agriculture is facing renewed pressure to use fewer resources to become more efficient and be more sustainable. The small robot company based in Salisbury, England, has come up with an idea that checks off a few of those boxes. Using artificial intelligence and precision agriculture technologies, it has come up with a system that allows farmers to manage each plant individually, even though there are billions of plants in one field. Here's my conversation with one of the company's lead executives, Ben Scott Robinson, who was in Regina recently to participate in an Ag Tech Accelerator program. This collaboration between Connexus Credit Union's Cultivator Initiative, Economic Development Regina, and Emertech is designed to position the prairies as a global hub for ag tech investment, commercialization, and job creation. I started by asking him why he was in Regina in the first place. Hi, Ben. Thanks for joining us on Between the Rows.
Hi, Laura. Thank you very much for asking me along.
So what brings you to the Canadian prairies this week?
So I've been lucky enough to be invited along with 4 other ag tech startups from the UK to join the Saskatchewan Ag Tech Accelerator, which is just a fantastic program to support the growth of ag tech innovation in Saskatchewan and in Regina.
Now, you have come to Canada with a new way of thinking about getting the work done on farms. And from what I understand, this is something that can help farmers make, not only get the job done, but make them more efficient at the same time. And it's a team of workers. Tell me about Tom, Dick, Harry, and Wilma.
Yes, so we are building a suite of robots called Tom, Dick, Harry, and supported by the brains of the operation, Wilma, which is an AI-driven operating system. And their job is to ultimately deliver arable crops, cereal crops, from before planting all the way up to the point of harvest.
Now, how do they do that? What kinds of roles do they play in this?
Well, the key thing that we're doing here, I think, is rethinking how a farmer can see their crops. So with the increasing level of capability of sensing equipment on farms, farmers have been able to move from a sort of field scale view, maybe looking at 100 acres or 200 acres in these big plains farms, down to sectional views. But what we're doing is approaching it from the other perspective, and we're providing per plant farming. So the capacity of being able to have a near real-time view of every single crop plant in the field, and then the capability to go back and apply timely and efficient treatments to those plants to achieve their best potential.
This takes the concept of precision farming to a whole new level.
It certainly does. And to put it in context, in your average acre of land, you will have round about 1 million to 1.2 million wheat plants. So to be able to do that across a farm of 10,000 acres, requires a huge amount of processing capability, some very clever artificial intelligence, and a way of being able to disseminate that information in a way which is usable by the farmers and by either existing technology or our treatment technology as well.
Can you walk me through the process? Tell me how this might work in a practical field application.
Absolutely. So our Tom robot is a ground-based robot, and he lives on the farm. He is completely autonomous, which means at the moment he works an 8-hour day and a 5-day week, but ultimately he will be able to run pretty much continuously except when the batteries are charging. And he can just go up and down all day, every day, looking at or collecting data, imagery and different types of data on the field. And then that information is then passed to Wilma, the operating system, who then processes that information to find the location of each plant, essentially name and number that plant, and then look at how it's growing through the season. So Tom goes back out into the field and will be covering those plants every couple of weeks. So we'll be able to see the growth of that plant over that time. And then as we understand how that plant is growing, whether it needs a bit of support with more nutrients, or maybe it's suffering from a disease, early stage disease, or maybe there's a start of a pest outbreak there, then Wilma will be able to tell our Dick robot to then go out in field and either feed it the nutrients it needs or treat it. So that first bit with Tom and Wilma we call per plant intelligence. And that is live now in the UK, admittedly in smaller farms and smaller fields, but we're working at a commercial pace and rate there. And to start with, we can provide that information as a treatment regime for existing spot sprayers, which really reduces the amount of chemicals that are being used. So it has a big impact on the herbicide that's needed to be applied in field. But also a big impact on the nutrients that can be applied. And obviously with the cost of both glyphosate and nitrogen being at all-time highs, this is something that farmers are very interested in at the moment.
So as I understand it right now, Tom goes out and collects the data, Wilma processes it, and informs the farmer to go out using maybe conventional means to support that crop, either through pest management or extra nutrition.
That's exactly right, yes.
Okay. So, but from what I'm hearing is that the Dick component of this process, you are actually able to go out and do things in a different way to control weeds, for example. Just describe how that might work for me.
Yes. So the Dick has a multitude of jobs, but the main one is around precision spraying at a whole new level. So moving down to a per plant spraying capability. But with weeds particularly, what we are keen to do is to use non-chemical means to control those weeds. And right now, we are trialing at field scale an electric non-chemical weeding system. So literally going up to the individual plants in the field and running an electric current through them to systemically kill that plant. Now, because we have this per plant view, we can also understand which of those, we like to call them non-crop plants, are a threat to the crop, will reduce the yield and have an impact on the farmer's bottom line, but also which of those plants are actually not a threat and actually might help. So things like clovers can lock nitrogen into the soil, and sort of prairie flowers can encourage the return of more biodiversity. So we are looking to be quite subtle, I suppose, in the way that we're doing it.
And where does Harry fit into the picture?
So Harry is a precision planting system, and with the idea that we are planting each seed at the right depth and spacing, so that plant can achieve its full potential in those soil conditions, in those humidity and rainfall conditions, so that we can get the maximum yield out of that plant.
When you look at farming in the UK versus farming on the Canadian prairies, there's obviously some differences in the size of fields, and I think there's differences in the productivity. How do the economics work out?
So as it stands at the moment, the way that prairie farming works is more efficient and more cost effective, certainly per acre, than what is achievable in the UK. But also there is a very different level of yield. So the reason why I'm here is to really understand the prairie system better, to be able to work with farmers here. And I've been very privileged to meet some outstanding prairie farmers from Saskatchewan who have been very open to talk about the way they work and how they would like to make their farms better, so that we can understand how we can deliver to 100-acre, 200-acre fields rather than 10 or 20-acre fields like we have in the UK. But hopefully how we can also help both make their system more efficient, but also hopefully increase yields as well.
Do you see this as being scalable across all types of farms and all sizes?
I think that the system of per plant farming is infinitely scalable. All the challenges around the data and the amount of information, those challenges have been solved in other industries already. And if you think about the complexity of how, Amazon works, for example, you realize that understanding the location of billions or hundreds of billions of single data points which are in one place is actually, not a particularly big problem to solve. Whether the machinery, whether Tom, Dick, and Harry look the same in Canada or on the plains as they do in the UK, I doubt it. I suspect that the Tom, Dick, and Harry will have a very different appearance here, but ultimately they will be able to achieve the same result.
What type of farmer is most likely to adapt this first to their system?
So I think there are two sort of types of farmers that will be most interested in looking at this sort of system now. One is, I guess you'd call the sort of transgenerational farmer, the farmer who are looking at their land, who are looking at the legacy of their farm, whether it is because they are about to pass it on to the next generation or they have just inherited it. And they will be thinking about, how can I make this farm work for the next generation? How can I make it, make sure that we maintain soils in an effective way? How can we apply with the new sort of consumer and government demands around reducing chemical inputs in fields while still maintaining or hopefully increasing yields? And then on the other side, I think that there is just a straight commercial benefit. The use of per plant farming radically reduces the amount of inputs that need to go onto a field. And that allows for farmers who just take a very commercial view in how their farm is run to realize that, to in a way to remove the reliance on things that are outside their control, like input costs, as we're seeing at the moment, and bring the control of the cost of their crop closer to them so that they can produce even more efficiently.
When you say there could be a radical reduction in the amount of inputs used, do you have any numbers to quantify that for me?
Certainly. So the first data pass that we have been doing in the UK, looking at weed distribution, shows that we can bring down the use of herbicides using existing machinery by somewhere between 60 and 80%.
Wow.
And because we know where those plants are in field, we can be very precise with the amount of chemical that the sprayers or our DIC robot takes out into the field. So there's no wastage. So that is obviously a huge benefit. Then in terms of nutrient application, we are currently seeing incredible savings opportunities in understanding the variation of plant sizes and distribution and emergence rates in fields, which are, pretty much invisible to the naked eye or even to a drone, which look like we can bring in substantial savings there. We don't have numbers around that yet. We're still in the process of crunching those, but it's looking like a significant saving. And then the final one is being able to understand when disease or pests first break out in the field, either when that is very first visible on just a few plants, maybe in the middle of the field, which is very hard to see if you're an agronomist or a farmer, or even before it's visible on the plant at all. And what we want to do, and this is our ultimate goal, is to give farmers the confidence to not spray fungicide just in case, but to have the confidence to say, I know my field does not have disease. So I know that I can step back from that particular application without fear of losing yield.
Ben, how long do you think it'll be before you really understand enough to perhaps look at implementing something like this in a Canadian context?
So one of the really exciting things about being here in Regina today is that it has given me the chance to talk to all the people in the area, all the real forward thinkers within the Saskatchewan farming community and also manufacturing and distribution community to be able to start that process of being here. It will take at least a year for us to be able to initially gather the data to have meaningful understanding of what's here. But we are keen to get here as soon as possible with our Tom robots to be able to gather that data. And once that data is gathered and we also understand all the requirements for the Tom, Dick, and the Harry robots here, and we can train the algorithms within Wilma to work in Canada, then we will be looking to help farmers as fast as possible.
Well, I'm looking forward to seeing how this turns out. Thanks very much for joining me today, Ben.
An absolute pleasure. Thank you for asking me again, Laura.
I was speaking with Ben Scott Robinson of the Small Robot Company in the United Kingdom. This technology is starting to pay its way on British farms, but cereal crops there are 7 or 8 times better yielding than what we might see here under prairie conditions. I asked Saskatchewan grain farmer Terry Aberhart about the potential he sees in this technology.
Well, I think there's huge potential in per plant evaluation. It seems an incredible stretch from where we are today, especially in large area farming areas like in Western Canada or different parts of the world, because we've kind of gone from to this kind of mass scale of efficiencies and things like that, very large equipment to cover ground. But really the reason we moved in those directions was because of human resource limitations and trying to cover more acres. And the larger equipment gets, and that maybe creates efficiencies as far as what you get done in the field, but it creates also a lot of other inefficiencies with how accurate we're applying inputs and where they're needed. And let's face it, we're going through an evolution in the world today where that probably just isn't good enough. And when we look at how, like even spraying technology and looking at green on green spray sensing and things like that, well, going across a field with a 100-foot wide or 130-foot wide boom, just mass broadcasting chemical, when you think about it in that sense, is really a bit of an archaic method of going about that procedure when we think about the technology that's available to us today. So simply, I think that it is probably a big stretch to think about how we can take smaller machines and or smaller robots and scale it. But on the same hand, those machines, they don't need holidays, they don't need to sleep, they don't need to eat, those kind of things. And so I do believe we'll get there. It's just a matter of time, and it'll look different. But I do believe we can get there.
We're sort of on the cusp of a convergence between this intergenerational transfer. Like, we're seeing a lot of older farmers that have been doing broadacre farming that are at the end of their careers, and we're going to see a new generation taking the helm that's maybe more digitally oriented. Do you see that being a spot where this might accelerate uptake of this kind of approach?
I think they will somewhat accelerate the adoption and what we're doing, but I think it's mainly just going to be driven by the market, right? Like, as inputs get more valuable, as inputs get harder to get, supply chain, as the value of the crop goes up, it creates more margin and opportunity. So I've always said this with precision agriculture and new science and technology. Usually what happens is the cost of implementing something either remains the same or actually reduces over time because of, it's a lot easier for us to develop or deliver a variable rate program today than it was 10 years ago, right? Everything gets better and more efficient. And then the value of what we're getting from that activity is increasing over time because inputs are going up and the value of the crop is going up. And that ebbs and flows based on the market, but over time, long term, those things only go up. So the cost of implementing it either stays the same or reduces over time as the value increases over time. So we're going to get to a point where others in the market are using technology that's more efficient and can produce at a lower cost or create savings. And eventually that, like anything, it'll spill out to where if you don't keep up with the Joneses, so to speak, you'll be struggling with profitability, or, we always talk about in life and business, it's a lot like a plant. You're either growing or you're dying. There's no static state. So in my mind, if there's a farm or business that's saying, well, we're just gonna sit still for the next 10 years, like, you're not actually sitting still. You're going backwards as the rest of the movie industry is moving ahead. So we need to always be keeping up with that.
What excites you the most about the kind of technology that companies like Ben brings to the table?
Well, what excites me the most is the potential efficiencies long term, the potential safety, the benefits to the environment and sustainability. There's just so many things. There's so many things, right? And I think it's a shift of thinking, but there's just so many opportunities. And unfortunately, in agriculture, we get beat up a lot like we're not doing things very well. But I think we're probably doing things better than a lot of industries. And I've always believed there's no other industry that worries more about the next generation than in farming. So most farms are always actively looking at protecting the land and the soil for the future to make it better, versus just grinding out the profits and dine and dash kind of thing.
So in your dreams, when you look 10 years up the road and you've got Tom, Dick, Harry, and Wilma, or whatever name that has when it comes to your farm, what kind of decision do you see that helping you make?
Almost all of them. I mean, one of the biggest challenges in agriculture today is the amount of information that's coming at us, the amount of information and decisions that we have to make on a daily basis. So the reality is, working with, it's not only going to be autonomous machines, but it's AI. So I cannot. There's no possible way anyone could fathom looking at every plant, even in a couple acre plot, right? Like, it's not even fathomable as a human being. But with the machine, that is possible, and it's being done and will be done. And so when you can aggregate this huge amount of data, we heard for years about the value of big data, and I think it's a bunch of BS in my mind, because data is worth nothing if you can't make a decision from it, or there's not some kind of intelligent output. But what I'm excited about is what I like to call intelligent data, and that's when we take all this big data and we put it into something that we can make a decision with very easily with data. Lots of times in the farm, especially in the past, there's a lot of decisions that were based off kind of emotion or your gut, or do we think it's going to rain? By golly,
and a little bit more for insurance.
That's right. And but we're moving to an area where that's not good enough anymore. And there's too much to risk there. So when you can make decisions from the data, it's way easier. It's a lot less stress, and you're probably making a much better decision on average. So that's where the opportunity is there, I think.
That was Terry Aberhart, a Saskatchewan farmer who sees a bright future for robotics on his grain farm. The small robot company was among 16 companies participating in the AgTech Accelerator program. Their ideas run the gamut for solving some of agriculture's biggest problems, everything from labor shortages to livestock wastewater recycling. While many of the faces at this event were new, I've found one longtime AgTech business starter who was back to launch his newest big idea. Rob Saik has launched a fistful of companies over the course of his career. His most recent effort is AgVisor Pro, which he describes as a hybrid between telemedicine and eHarmony, a service that links farmers who have a specific question to an expert who can help find the answer. Rob and I talked about how ag tech startups are changing the innovation game.
Now, these options, these technological options, are becoming far more prevalent and far more available, far more accessible financially. Where are we with uptake?
Well, uptake, trying to reach farmers and the broader agriculture community is very difficult because it's a very disparate, geographically spread out, and psychographically you've got everything from 30-year-olds who think like 70-year-olds, and you've got 70-year-olds who think like 30-year-olds. So, for AgVisor Pro, it's a digital platform, so we're trying to reach them, Lorna, on the digital highway. So people that are on their phones, and, farmers are on their phones for up to 3 to 5 hours a day. You wouldn't think that, but they are. And so we want to reach them where they're living, and they're living on their phones and the digital highway. So that's the challenge right now, and that's how we have to reach them.
And how do programs like this fit into that scenario?
Well, we were talking about this. And so if you think back to when you and I started our careers, the innovations, when we were younger, the innovations came out from the companies like Elanco or Herbst, Cyanamid. And we waited for the big companies to have the innovations. John Deere and Case would come out with an innovation. Today, the innovations are coming from all the startups, and their startups are being acquired by the big companies. But the technology that we have right now, the phone that you're holding in your hand, the computers that we're using, allow startups like here at the Cultivator Accelerator, we have 16 companies from Canada and the UK that are all having ideas and bringing those ideas to life that could impact and make a difference to farmers like Terry Aberhart, who's talking right now. So this is an exciting time. So the innovation is coming from new places, and often, Lorna, the innovation is coming from non-farm kids. It's coming from people not connected to agriculture. So they have an idea, like I was talking to a physicist the other day out of California, who's got an idea on how to do multiple testing of products on a field. He has nothing to do with agriculture, but they're looking for a way to make a difference. And I love it. I love the fact that these people are young and passionate, and they want to take an idea. Next challenge for them is to, commercialize it and then scale it.
Perfecting the idea is one thing. Attracting the investment to commercialize it is another. Saik says for every good idea that makes it, there will be a few that don't.
Back in the day when I started Agritrin, we started Agritrin, and I would soil test, make recommendations, charge a farmer, get some money, make some profit, make it, grow it. But a technology company requires literally millions and millions of dollars. Every day I wake up right now and I crumple a bunch of cash and throw it on a fire. And I give it to all the people. We have about 30 people working right now. And who knows whether we'll make it or not. These companies here, some will make a real difference, and some might not make it. But it's those that do that change agriculture.
That was Rob Saik, an Alberta entrepreneur who was participating in the recent AgTech Accelerator program held in Regina. That's all we have for you on this week's Between the Rows, but we'll be back again next week. Thanks for joining us. I'm Laura Rance.
We knew we were doing something right when our competition started swearing every time they talked about us. Just the other day, I heard someone saying, "Have you seen this f***ing Seedmaster Ultra Pro 2? They got third-party PAMI testing that confirms its individual row metering delivers uniform f***ing seed placement, near zero seed mortality, and no impact on f***ing germination results." We take it as a huge f***ing compliment. Start raising your f***ing ROI at seedmaster.ca.